Good morning, everyone. We have a demo next. Please join me in welcoming Book Leong, VP and Head of Deep Brain at ST Engineering, coming all the way from Singapore. He will be demonstrating the AI Sensemaking Platform with multimodal analysis capabilities to support complex, time-critical operations.
Good morning, everyone. My name is Book Leong. So for today, I'm going to share with you our AI sense-making platform that we have developed over the past couple of years. So first things first, what's ST Engineering? Actually, we are a company founded in Singapore. We are actually a listed company on the Stock Exchange of Singapore. Really started out as a defense contractor, but over time, we have evolved. Our business has evolved to work on digital platforms for the customers. So these are some of the projects that we have done globally, as well as in for our local customers. It ranges from platforms such as bus, all the way to digital platforms such as the real enterprise asset management systems, which is a collection of log data, log information from our real assets. So for today's topic is about how are we implementing AI? We have developed AI platforms the past couple of years, really designed for customers in the mission critical domains. So for today, I'm going to showcase to you how we actually implemented this for emergency response systems. So for this customer in particular, it is our local fire department. For customers who engage us, there will always be a problem statement. For them, they want to be able to achieve less than 12 minutes in response time in a highly urbanized environment. So what we have delivered and put forth for them is to create a solution that is able to do automatic speech recognition across multiple languages. So in Singapore, we actually have a local licensed form of English. We call it Singlish, which is a mix of English, Mandarin, and Malay. So we have developed a speech model to be able to transcribe text. And we also put in video analytics to extract key information from unstructured sources such as CCTV feeds, as well as social media data feeds, to allow the commander to make sense of the situation. And last but not least, when we have integrated data from different modalities, we then create an integrated sense-making engine to make calibrated decisions for the commanders. So this is what we think of as a concept for multimodal sense-making. Having data across different domains, developing purpose-built engines to extract key information from the data, integrating them to generate insights, and more importantly, create situational awareness for the commanders. So for this customer, who are the personas that we are helping? In this use case, there are two key personas. First is the commander, or what we call the watch officer. So this person is actually the overall in charge of the op center. What we have wanted to do is to be able to create a timely picture to improve his situational awareness. And more importantly, where we see the most operational gains is actually for the operator. So the operator in this scenario is the person at the end of the emergency call. So in Singapore, for fire and medical emergencies, we call 995. So it's a little bit of your equivalent of 911 in America. So for the operator, we have actually put in a virtual assistant to listen in to the conversation, transcribe the speech to text, and we put natural language processing to extract key information and help the operator generate a form. So what I'm going to demonstrate to you is a couple of scenarios where the AI system actually helps the operator. So in the first scenario is about speech to text, where when a member of the public calls in, the call taker will pick up the call, communicate with the caller, extract key information, while the AI in the back end will listen to the conversation and fill out the form for the user.
Hello, this is 995. How may I help you?
So as the call
Hi,
comes
yeah,
in,
I need
on
ambulance
the
now.
left,
There's someone lying down
you'll
there
see
unconscious.
the transcript
Okay,
being
Can you
generated
give me
live.
the address?
I'm not very sure. I'm in Punggol below this HDB, block 270B.
Okay, let me check.
So as the conversation takes place,
Is it at
the AI will find the key
270
information and fill up the
Punggol
form
Field?
on the left.
Yeah, I think so.
Okay, what happened there?
This Encik, he's lying down there. I think he's unconscious. I called out to him, but he's not responding. And got a pungent smell in the air. It's like Mao Shan Wang Liu Lian like that.
Okay, unconscious. Is he breathing?
I think his breathing seems quite heavy. Looks quite jialat.
Okay, how old is he?
I think he's around 50 years old.
Okay, please hold on. I'm rushing out the ambulance for you now. How may I address you?
John.
Okay, John. Help is on the way already.
So in this scenario, really, the human operator can focus his effort to comfort the caller. At the same time, let the AI do the heavy lifting of extracting information and populating the form. So if you look at across the dialect, the conversation, we have actually built in the multi-language engine where we can do code switching between Mandarin, Malay, and English. So in the next scenario, we are looking to help the watch officer. So the watch officer has a very critical task that he needs to do a lot of decision making in how to respond. So in this scenario, we actually recreated an event, a major event that has happened in Singapore more than a decade ago. There was actually a riot in one of our towns. So as you know, in Singapore, a riot is a big deal. It doesn't happen very frequently. So now what we are trying to showcase is with AI, how will it look like for the commander? So as the call comes in, we have an event fusion engine in the backend to help the user connect the dots. For large-scale events, different users can call in describing the same event in a different way. What we wanted to do is to help the operator deduplicate events so that they do not respond to the same event. We also put in the computer vision models to identify chaotic scenes and surface relevant scenes to the watch officer so that they do not need to monitor 24/7. So chaotic scenes, we will extract and box out key objects identified in the scene. And also because it's the fire department, we also put in a fire detection model. So if you see the numbers around the bounding box, these are actually the dimensions of the fire. For large-scale events, there will be social media feeds coming in as well. So what we have done is to analyze the social media feeds, categorize the events, and organize them in a chronological order for the commander. So traditionally, these kind of systems, the user will have to look through 3-4 different systems. By using our AI platform, we integrated this analysis automatically into a single platform so that the user can have a one-glance view to appreciate the situation and make the best possible decisions. So these are what we call traditional machine learning AI platforms. So now with the advent of generative AI technology, I think the potential is even greater. So what we have started to see is to proliferate the technology that we have seen earlier into different scenarios. So the first scenario will be about enhancing man-machine augmentation. So we see it in 3 different levels, starting from the virtual assistant mode. So in the earlier presentation, you have seen it's largely the AI assisting the human in the process automation and also the information extraction. So moving on with generative AI technology, we see co-piloting and digital mentor being a possibility. So we started to implement new systems into healthcare. So in this example, it is a psychiatrist consultancy between a doctor and a patient. So as you can see, the concept is the same as previously. The dialogue is transcribed, analyzed, and tagged to the appropriate field in the form. So what you see in this demo is actually more complex and sophisticated summarizations, which are generated by the large language model. And the next level is to actually use it to help suggest to the user recommendations to help in decision making. So in this example that you see now will be what we call a digital mentor, where the AI will assist the doctor in identifying symptoms, doing the diagnosis, and also prompting the doctor the set of questions to ask.
Good morning, Miss Tan. How can I help you today?
Hi, doctor. I have a bad sore throat. Very pain when I swallow.
I see. How many days has it been?
It started last night and got worse today.
Any cough?
Sometimes the throat a bit itchy, then will cough. Got some thick phlegm. Then my
So,
throat
so
feel
as
very
you can
weird
see
when
in
I
this
talk.
demo, as the patient
And
is
my ears
articulating
like
her
blocked.
symptoms,
A
the
bit
AI is
pain.
listening for the symptoms,
Okay. Do you have any
just
fever
writing
or
a summary
chills?
about the symptoms and looking
Last
at the
night I checked,
journal or
got
historical
a low
cases to make a
fever.
diagnosis. So what
Any
you see
nausea?
at the left corner is a set of questions that the AI suggested the doctor to ask. So in the back end, we actually stitch together a set of medical corpus together with, in addition to the best practices and journals that the doctor should follow. So these are actually automatically analyzed by the AI and designed to augment the human. So last but not least, this is my last slide. Trying to harness the capability of AI is really a journey. You do not start, all these capabilities are not delivered from day one. Actually, it is a very calibrated steps that we take to be able to build up this cap. So we see it as the integration of a business, people, and technology. So business, we need to create platforms that that users will want to buy and use. And we must train out the people and equip them with the correct technology to be able to make AI platforms sustainable. So this wraps up what I've wanted to share. Thank you very much.